notes. We're going to take this page and we're going to fold it in just like this so that this line hits the pink line. It's going to leave a little bit of a border here. So we're going to turn it sideways. And we're going to write exponent laws right here. All right, our exponent laws. And this is going to be a page in our notebook. This is going to be page 11. All right. So what we're going to do next is we're going to take this paper, we're going to get some scissors, and we're going to eyeball it. It does not have to be perfect. What I want you to do is I want you to find about halfway along the paper, and then I want you to cut it in half right here, okay? And then you're going to eyeball each half, and you're going to cut each strip like so. So we're creating creating 3 flaps on the top, and then we're going to create 3 flaps on the bottom. And please do not think it has to be perfect, because it does not have to be perfect. Okay. All right. So once we have these 3 flaps, we're going to turn this back the right way, and we should have a total of 6 flaps in all. And we're going to look at our 6 exponent law rules on these flaps. Okay. So getting started, if you need to, you can pause at any point in time, and you can pause it and then restart it when you're ready. Okay, so let's start with our first exponent law. Our first exponent law is called the product of powers. So we should know what product means in math. Product means multiply. So that could be parentheses, it could be the dot, or it could be the multiplication symbol. You guys know I'm not a fan of the multiplication symbol simply because it gets confusing with variables. So what is product of powers? So this is where we're multiplying powers or multiplying exponents. So what the rule says is when multiplying exponents with the same base, here's what we're going to do. We're going to keep the base, and we're going to add the exponents. Okay, so we're going to have 2 examples here. We're going to have an algebraic example. We're going to have a numerical example. So the algebraic example for this rule is you have x to the n power times x to the m power. This is the base, okay? These are the bases. The exponents are the little numbers. These are the same bases. So we keep the base, and we're going to add the exponents. All right, so we're going to add n plus m. All right, now we don't know what n plus m is, so we're just going to leave it alone. But if I was to do another example, a to the 2nd times a to the 8th times a to the 7th, we're going to add 2 plus 8 plus 7, keep that base of a. You all know what that is added together. That's a to the 17th power. That is our rule. Okay, so this is the rule for product of powers. If you need to, pause this video and write this down. All right, our next rule is quotient of powers. So we should know that quotient in math means division. Now we're usually going to see this written as a fraction. We're going to usually see division written as a fraction. So I'm going to do a fraction bar. Okay. So what is the quotient of powers rule? So if we are multiplying, we're adding. Dividing, we're going to subtract. So when dividing exponents, with the same base, here's what we do. We keep the base, and we're going to subtract the exponents. Okay, so our algebraic example is I have x to the m divided by x to the n. What we're going to do is our answer would be we would subtract these from each other. Okay, so our numerical example, if I had b to the 10th divided by b to the 4th, we're going to keep the base b. we're going to do 10 minus 4. We're going to get b to the 6th power. Okay, and that would be my answer. All right, so when we are multiplying, we add. When we're dividing, we subtract. All right, our next rule is a really kind of easy rule, and that rule is about zero exponents. So I'm going to go ahead and do zero exponents next, so it helps you guys out. Okay, so what is the zero properties of exponents? The zero property of exponents. Probably our easiest and our favorite rule, and that rule says any number or variable that is a base raised to the 0 power is 1. So we want to say it's 0, but it's actually 1. Okay, we want to say it's 0, but it's actually 1. So what does that mean? Let's look at this. So if we had x to the 0 power, it becomes 1. We had a to the 0 power, it's 1. If we had this whole expression, x to the 5th, y to the 6th, z to the 8th, raised to the 0 power, that whole thing becomes 1. So it's probably our easiest rule, and it's probably what we're gonna like seeing the most, okay? So any number or variable that is a base raised to the 0 power is 1. Pretty simple stuff, guys. All right, our next rule is the product, or not product of powers. Oh, I've already done that one. The power of a power rule. So it's the power, right, like this. Power of a power rule. So it's when we're raising a power to a power. Okay, power of a power rule. So what does that rule say? Okay. When raising a power to a power, multiply your exponents. So what does that mean? When raising a power to a power, multiply your exponents. Let's look at some examples of this. Also, again, I know I'm going quickly, but if you need to, pause this video. Okay, so our algebraic example is if I have the power x to the n raised to the m. What we're doing is we're multiplying. And y'all, this one that you need to understand, this whole thing is called a power. Okay, so you've got the base, you've got the exponent, the whole thing is called a power. So a power raised to a power. So what we do is we multiply them, we get n times m. So our algebraic example is if I have a to the 5th raised to the 6th, we're going to multiply those and get a to the 30th power. Okay, I'll do one more. If I have 2 to the 3rd raised to the 4th, we're going to multiply those. I have 2 to the 12th power. Okay, that is the product of our power of a power. All right, our next rule is built on this rule and these two rules at the top, and that's power of a quotient, which we know is division, or product, which we know is multiplication. Again, I'm doing parentheses, all three symbols. All right, power of a quotient or product. Okay, so what does that rule say? It builds on these other two, and it basically just says to find a power, the power of a quotient or product, multiply all terms in parentheses by the exponent. So let me write that out. What? To multiply or to find the power of a product or quotient multiply the exponent of all terms in parentheses by the outside power. So what that means, okay, again, I know I'm going fast, so if you need to pause this video. All right, what does that mean? That means that if we have, for example, x to the n, m, well, the m to the d raised to the k power. All right, we're going to multiply both of these by k. So we get x to the nk, m to the dk. Okay, now I know that's really confusing with all those letters, so let's look at it with some numbers and letters. So if I have 4x to the third, and we're raising this to the second power, what we're going to do is we're going to multiply the 3 and the 2, and guess what? This 4 is to the first power, even if I don't see it. So we're going to multiply the 2 and the 1. So this really means 4 squared x to the 6th power. And you guys know that 4 squared is 16. So this becomes 16x to the 6th power. Okay, another example. If I had a to the 8th, b to the 6th, and c to the 2nd, and I'm raising all this to the 3rd, we're just going to multiply each of these exponents inside by the exponent on the outside. So I have a to the 24th, b to the 18th, c to the 6th power. And that is how we do product powers. It would be the same thing if it was a division problem. I know I didn't put a division problem on there, but we would multiply everything in the numerator, all the exponents in the numerator, and all the exponents in the denominator. Okay. And our last rule we're going to talk about is our negative exponents properties. Okay. Our negative exponent properties. So we'll put a little negative out front. All right, so this one's really, really important because we can never, ever leave our answer with a negative exponent, okay? So there's two ways to do this. For any negative exponent, make a fraction, put the term with the negative in the opposite location, and then make the exponent positive. So what does that mean, the opposite location? Okay, so for example, if I had x to the negative n, what I'm going to do, I'm going to make a fraction. Right now, I don't see anything other than this whole problem, okay? This is really over 1, even if I don't see it. So it's opposite location. This is technically in the numerator of this fraction. We know everything is over 1. This is in the numerator. We're going to move it to the opposite location, which is the denominator, and make the exponent positive. But then we still have to put a 1 on top because we're now in the denominator. We have to create a numerator. All right. The other way we can look at this is if we have a fraction and the exponent's negative in the denominator, we put it in the numerator and make it positive, and we put it over 1. Would you guys understand that that could just be written like this? So if there's no denominator, that means we put it in the denominator and we add a numerator. If it's in the denominator, we put it in the numerator, and then we can just write it without a denominator. So an example of this would be if I had a to the negative 7th power. We're going to put it in the denominator. We're going to make it positive. We're going to put a 1 on top. Okay. Another example, what if I had x to the negative 5th divided by y to the negative 2nd? Okay, so we make our fraction. We're going to go opposite locations. This is in the numerator, so we're moving it to the denominator and making it positive. This is in the denominator, so we're moving it to the numerator and making it positive. And that's an acceptable answer because there's no more negative exponents. Okay, so this video goes over all 6 of our rules rather quickly. I know that, but now we all have them in one place on page 11 of our notebook. And then what you're going to do is you're going to start with your lessons on this page, okay? So please check this out. Make sure this is in your notebook because these rules are important. And I look forward to practicing these with you in our class sessions. Have a good day.